All right, today we're going to talk about the three phases of matter. We have solid, where the particles are close together, have a definite volume, and a definite shape. We have liquid, where the particles have a definite volume, but they do not have a definite shape. Their shape is defined by their container. And finally, we have particles in a gas, all over the place. They are completely random. They do not have a definite volume. They do not have a definite shape. In fact, gases expand to fill their containers. Even though there was alcohol in here, there is now air in here, which is contained mostly of oxygen and nitrogen. When I open this up, this air can enter or leave this container, and it will expand to fill this exact shape. Now, how do we determine what phase something is in at STP? STP, all that means is standard temperature and pressure. And it's equal to 273 Kelvin or 0 degrees Celsius. But when we're doing math problems, we don't use the Celsius because you don't want to multiply by a 0. And the Kelvin is more of a universal scale that we use in science classes. So let's look at some of these elements. Get out your reference table. I have right here, I'm going to look at 500 degrees. So at 500 Kelvin, what phase is sodium, or Na? So the way that we figure out these questions is we first determine where the melting point and where the boiling points are. So if we consider this as a number line, we have 273 Kelvin. 500 Kelvin is going to be greater. So let's just put this as 500 K. Way down here would be 0 K. And since we can't get lower than 0 in the Kelvin, this is considered absolute 0. Now I'm going to look at sodium's information from table S, and I will determine when the melting point and the boiling point, where they are found. The melting point for sodium is 371 Kelvin. So melting point is 371, which is somewhere in between 273 and 500. So let's just go ahead right here, and this is 371 K, and this is melting. Now the boiling point of sodium is 1156. So that's way the heck up here. 1156 K, and that is boiling. So what this means is anything less than 371, it will be a solid. Anything above 1156, it will be a gas. And anything between 371 and 1156 is going to be the third phase, which is our liquid phase. So at 500 Kelvin, what phase is sodium? 500 Kelvin falls in between the melting point and the boiling point. Sodium would be a liquid. Now let's look at another way of asking the question. So we have to say, what phase is sodium at STP? So we're going to look over here at our information. STP, as I said before, it is 273 Kelvin. At 273, we've already established that it is less than the melting point, which means you have to heat up the sodium past 273 Kelvin, keep going until it gets to 371, and then it will start melting. So anything down here, it is going to be a solid. All right, I'm posing another question to you. Which halogen, or group 17 element, is liquid at STP? So what I did here is I wrote down the different halogens that we're going to be comparing. And I look at my information on table S. I'm going to write down the fluorine's melting point, or MP, is 53. Boiling point is 85. Looking at chlorine, it is 172. And we go to 239. Going down, we're going to look at bromine, which is 35. It is 266. And its boiling point is, just add it, is 332. And finally, iodine. We have iodine is 387 and 457. So 387 and 457. Now, when you see a question like this, there's another trick you can use, is you can treat this as a little mini number line. If the number falls to the left, it's going to be a solid. If the number falls to the right, it's going to be a gas. And if the number falls somewhere in between, it's going to be a liquid. So we're going to look at this right here, STP, which means 273 Kelvin. So at STP, fluorine, solid, liquid, or gas. Which direction, where does 273 fall on this number line? It is far, far to the right. Fluorine is going to be a gas. Now looking at chlorine, 273, is it in the solid, the liquid, or in the gas? 273 is to the right of this. Chlorine would also be a gas at STP. Now bromine, at 266 and below, it's going to be a solid. Between 266 and 332, it's going to be a liquid. Since 273 falls in this gap, it looks like bromine is going to be our correct answer. But let's just verify with iodine. You always want to check all four. 387 to 457. Where does 273 lie? 273 lies to the left. This is going to be a solid at STP. So our correct answer, bromine, is a liquid at STP. In fact, there are only two elements that are liquids at STP. Here's a challenge. See if you can figure out which one it is. Bromine, there's one other one.